So next part we'll be learning is actually integration via substitution. Okay, so substitution is a little bit more clear cut per se, because when a question will need you to use substitution, there's no need for you to guess. Okay, the question will tell you, okay, please use substitution. So unlike the old syllabus where you actually require to form your own substitution, new syllabus generally doesn't. Most of the time, if you need to use substitution to solve a question, they will actually tell you. Okay, and the reason why we're actually using substitution is because we can't actually use any formula to solve, so we have to make use of a substitution. Okay, so I'm going to show you the example over here. Okay, I'm going to run through the example part by part with you, and after that you should be able to understand a little bit clearer. Okay, then we're going to show you the next 4 examples as well. Okay, so the first example, okay, the question asks for by using substitution u minus 1 equal to sine x. Okay, find square root integral of 2 1, okay, square root 1 minus u minus 1 squared. Okay, this is the first time we'll be playing definite integral here. So if you don't remember definite integral, take note, you have to go back and look at your secondary school stuff. Okay, if not, I'm just going to assume that you know your basic integration. Okay, this is what the question wants. Okay, you're supposed to integrate this with the help of your substitution u minus 1 equal to sine x. Okay, so what I'm going to do is, okay, there's 3 things that I need to do. First thing first, I need to make everything to in terms of x first. Okay, so over here, okay, I'll get u minus 1 equals sine x, so it will be 1 minus sine square x. Okay, that's the first thing that I need to change. Okay, second thing is, now I'm integrating with respect to x. Okay, so I need to change my du to in terms of dx. Okay, what I do is very simple. I'm going to find my du dx. Okay, is equal to differential of sine x will give me cosine x. Okay, you can sort of visualize it this way, okay, but never write this in your working. Okay, so what do I mean by visualize it this way is basically your du is equal to cosine x dx. Okay, this doesn't make any mathematical sense, but it's a very easy, good visualization. So what I'm going to do is I just simply replace my du with cosine x dx. Okay, so 2 things. Okay, first thing, we'll change all my u to in terms of x. Second thing is change my du to in terms of dx. Lastly, okay, is the 2 and the 1 here. Okay, the 2 and the 1 here basically is actually in terms of u. So you have to change to in terms of x. Okay, so how do I change it? Very simple. When u is equal to 2, okay, 2 minus 1 equal to sine x. So sine x equal to 1. Okay, and your x is equal to pi over 2. Okay, sine inverse 1 is pi over 2. So I'm going to change this quickly to pi over 2. Same thing, we're going to do the same thing for when u is equal to 1. Okay, so 1 minus 1 equal to sine x. Then sine x equal to 0. Okay, in other words, the sine inverse 0 is 0. So we're going to just leave it in pi over 2 and 0. Okay, then once you come to here, it's basically down to your integration techniques already. Okay, you should realize that there's a 1 minus sine square x. So what I'm going to do is I'm going to change it to using my trigo identity. Okay, cosine square x plus sine square x equal to 1. So 1 minus sine square x will give me cosine square x. So square root of cosine square x times cosine x dx. Okay, so further simplify, I'll get cosine square x dx. Okay, how do I integrate cosine square dx? This is in our MF formula MF26. We went through this before in our type 3 or type 4. I can't remember off my head. Okay, but essentially you need to learn how to integrate cosine square x. Okay, so integrate cosine square x, you have to change the formula using M36 to cosine 2x plus 1. Then from there, go ahead and integrate accordingly to get you pi over 4. Okay, so that's the clear example in this table here. Okay, what I'm going to learn next is part 1 over here. Okay, so I'm going to follow my step closely. If you can, don't need to write anything first. Okay, you can always pause the video to copy it down later. Okay, so same thing. This is an indefinite integral, which means that there are no upper and lower limit, we call that. Okay, so basically I'm just going to skip that step. Okay, so there's 2 steps for you to change. So first thing first, okay, I'm going to change to everything in terms of theta. Okay, so in this case, square root 4 secant square theta minus 4. Okay, the same thing, I'm going to quickly calculate out my dx over d theta. Okay, differential of 2 secant theta is 2 secant theta tangent theta from the MF26, differentiate of secant theta. Okay, so same thing, in this case will be 2 secant theta tangent theta d theta. Okay, so I change my dx to in terms of d theta. Okay, further simplify, you should remember the identity, sine square x minus 1 is equal to tangent square x. Okay, so this will give me 1 over 2 tangent theta. Alright, because square root, will give you square root of tangent square. So square root of tangent square will give me tangent theta times 2 secant theta, tangent theta from our previous part. Okay, you realize that the 2 will cancel out, the tangent theta will cancel out. So essentially, you should leave with integrate of secant theta d theta. Okay, and to integrate secant theta, okay, is basically from your MF26. Okay, so integral of secant theta is equal to ln modulus, okay, don't forget the modulus, okay, plus tangent, okay, so it's plus tangent theta plus c. Okay, is this the final answer? Unfortunately, no. We have to convert because the question is solving for in terms of x. Okay, my answer is in terms of theta, so I need to convert back to in terms of x as well. Okay, so how do I do that? Okay, x plus 2, x equal to 2 secant theta. So secant theta essentially is equal to ln modulus x over 2. Okay, for tangent theta is slightly more tricky, so follow me here. What I'm going to do is I'm going to draw a triangle. Okay, I'm going to put a theta. Of course, it's a right hand triangle. Okay, so if secant theta is equal to x over 2, cosine theta will be equal to 2 over x. Okay, using our Tuakaso, cosine is adjacent over hypotenuse, so you know that adjacent is 2. Okay, your hypotenuse is x. Okay, this will give me square root of x squared minus 4. Okay, so your answer here still have a tangent theta. So tangent theta is opposite over adjacent. So I'm just going to quickly plug in the formula. Opposite is square root x squared minus 4 divided by 2 plus c. Okay, don't forget the close modulus. Okay, so this is how we actually convert back. The triangle over here is a very common question. Okay, we're going to run through part 2 here. Okay, part 2 is slightly more challenging. Okay, I'm just going to quickly run through. So it's 4 over 2, copy down the question. Okay, so same thing, the question did ask you to use x equal to 1 over u. Okay, so let's go to x equal to 1 over u. Okay, the dx du will then be negative 1 over u squared. Okay, take note, what I'm going to ask you to do is, even let's say the integral is very, very complicated, I will generally get differentiate first. Okay, because most of the time there's a 1 mark given to the differentiation if you are getting correct. Okay, so that's number 1. I'm going to change everything to in terms of u. So it'll be 1 over u square root 1 over u squared minus 1. Okay, same thing. Then next thing I'm going to change to dx du times negative 1 over u squared. Okay, which is found previously. Okay, my upper and lower limit is the third thing that I want always remember to change. So in this case, when x is equal to 4, okay, u is equal to 1 over 4. Okay, when x is equal to 2, u is equal to 1 over 2. Okay, so what I'm going to do is I'm going to replace my 4 with 1 over 4 and half. Okay, take note, yes, some of the students, if you are quick, you should see that how come 1/4 is smaller, but it's at our upper limit. Okay, take note, if a substitution question, we don't generally change it so that we won't get so confused. Okay, so generally substitution, if the question asks you to do a substitution, okay, your upper and lower limit is the flip. Okay, please do not go and flip yourself. Okay, take note, the substitution will take into consideration of the flip sign. Okay, so don't go and change it to half and 1/4 because half is generally bigger than 1/4. Okay, essentially you will screw up your answer. Okay, so over here I'm going to just quickly guide you through the manipulation. Okay, of course the integration part I'm going to leave it to you. Okay, so what I'm going to do is I'm just going to combine them. 1 minus u squared divided by u squared times negative 1 over u squared du. Okay, take note, this and this can cancel away. Okay, so I'm left with integral of 1 over 4 half. Let's see. Okay, so you give me 1 over u square root 1 minus u square over u square du. Okay, the negative sign still remains. So in this case, it's going to be negative 1 over 4 half 1 over u square root 1 minus u square. Okay, essentially a quick manipulation, you should get negative 1/4 half 1 over square root 1 minus u square du. Okay, and if you are fast, you should see that this is a sine inverse formula. Sine inverse u, okay, 1/4 and half. Okay, the negative still there, so essentially it should give you a negative sine inverse 1/4 minus, or rather, yeah, plus Okay, minus minus plus sine inverse half. Okay, take note, this is not indefinite integral, so there's no need for me to put a plus c. Okay, last two, quick guide to you. Okay, you can go ahead and try yourself. Okay, a hint for you is that we are going to play with our trigo properties. Okay, hint for you. Sine square x plus cosine square x equal to 1. Okay, and of course, essentially you should derive a formula over here. Okay, your answer is sine inverse x over 3 plus c. Okay, part 2 is slightly more challenging. You can go ahead and try. Okay, but I'm gonna leave the answer for you and also a hint. Okay, once you compare everything, take note you have to do long division. So it's a lot easier for you to integrate. Okay, then it's a definite integral, so remember to change your upper and lower limit as well. Okay, the answer, same thing, will be 3 plus 2 ln bracket 4 over 3. Okay, of course I'm leaving it exact. Okay, take note, if the question did not ask you to leave it exact, you can actually use MF26 to find. Okay, but it's always a good method to help you check. What I mean is that use your MF26, key in this directly, and compare to the answer that you actually derive. Okay, see whether they are exact same numerical value as not. Okay, if not, that's it for integration via substitution.